and normal form of a metric. Let us understand what is this form and why do we use this form of a matrix in mathematics. So an echelon form has a format of a matrix which describes for every non-zero matrix A of rank R can be reduced to the form of a matrix is written over here. In a matrix here, you can see an identity matrix of order R is written, and apart from this identity matrix, rest of the elements left in the matrix is 0. Okay, so this is the format of echelon form of any matrix having rank R to it. Okay, so if A is any matrix with rank R, if it is reduced to this form by a finite sequence of elementary transformation, then this form of a matrix is known as echelon form of a matrix, or we call this format as first canonical form of a matrix as well. So we call this form of matrix as echelon form or first canonical form of any non-zero matrix A. So few examples of echelon form of matrix are here. Let me explain these example here. The order of a matrix is 3 cross 3. Suppose there is any non-zero matrix of order 3 cross 3. So how does its echelon form is going to look like? See here. So if it is going to have rank 2, then its echelon form will be like this. You can see the first two rows and columns are the identity matrix of order 2, isn't it? And rest of the values in the matrix is 0, isn't it? So if the matrix is having identity matrix of order R, then that R is going to be rank of the matrix, and the entire format of echelon form will be written as identity matrix of order R and rest of the elements will be entered as 0. That format of a matrix is going to be known as echelon form of a matrix, or we can say first canonical form of a matrix. Similarly, I have taken one more example to show echelon form of it. Suppose there is there is any non-zero matrix. I have not entered its element. I have just uh, shown that its order is 5 cross 6 and its rank is 5. Its rank R is equal to 5. So for this situation, if its rank is 5, how does its echelon form is going to look like? You can see over here. That means its echelon form is going to look like this matrix, in which I have entered an identity matrix of order 5 and rest of the elements are entered as 0. So if this matrix of order, this any non-zero matrix is reduced by some elementary transformation to this format, that form of a matrix is going to be known as an echelon form or first canonical form of a matrix. So depending on its rank, we can have the echelon form of it. So if its rank is 5, the echelon form of a matrix is going to have identity matrix of order 5 and rest of the elements as 0. Can you see that? Is the format of echelon form of a matrix clear to you all? How does its echelon how does echelon form of any non-zero matrix look like? Okay, so here I took example of one of the example of a square matrix which was of order 3 cross 3, and another example which is not of uh, order n cross n, that means it is not no. Another example of non-square matrix, how its echelon form is going to look like. Now, to get the echelon form of any matrix, we need to follow few steps of elementary transformation. Let's go through those steps. See, those are three simple steps that we have already performed in the previous topics of finding inverse, when we used the elementary transformation method of finding inverse, or we have gone through one of the topic of using matrices for solving system of n number of linear equations as well. Over there we tried transforming the coefficient matrix into an upper triangular matrix. So such kind of row transformations, first few steps that we had followed are going to be followed here as well, because here our idea for getting echelon form of a matrix is to get an identity matrix of order r. And what is r? R is a rank of a matrix. Okay, so now we know what is rank of a matrix, how to get rank of a matrix, how to calculate rank of a matrix, and now we have gone through the echelon form of a matrix, which has used the rank value to get echelon form, isn't it? So let us see one of the example to find the echelon form of a matrix, or to find rank of a matrix using echelon form of a matrix. So let's take an example. Here I take an example of any 3 cross 4 matrix I have entered over here. Let me name it as matrix A. So here is a 3 cross 4 matrix, and let's find its rank first. So if we try finding its rank, what will be the highest number of let me erase this. ये echelon form का मैंने example दिया है. अगर इसका rank 3 हुआ तो उसका echelon form कैसा दिखाई देगा? यहाँ पे उसका echelon form लिख के उसका example बताया है. If we find rank of this matrix as 3, so see here, first three rows and columns are written as an identity matrix of order 3, and rest of the elements are entered as 0. So as a whole, its echelon form is going to look like this form of a matrix, in which first three rows and first three columns are entered as identity matrix of order 3, and rest of the elements as 0. Okay, so this matrix is to be converted into this form of a matrix. Okay, so to convert the given matrix into its echelon form, we have to follow few sequence of row or column transformation. Okay, so first we are going to calculate the value of rank for the given matrix. Once we get the value of rank, then suppose just now I have explained that if we get the value of rank as 3, then its echelon form is going to look like this. In case now we don't know the value of rank over here, we are just assuming and getting writing the echelon form of it. For example, suppose I don't get the value of rank as 3, but I get the value of rank as 2. Suppose I get r is equal to 2 for this given matrix of order 3 cross 4. Then how its echelon form is going to look like, that also we will see. So first two rows, because r is 2, so first two rows and two columns are going to be entered as an identity matrix, and then the rest of the entries will be entered as 0 in the matrix. That means they are going to be reduced to this form to get the echelon form of the matrix. Are you getting my point? Have you followed the format of echelon form? for any general matrix. So if any matrix of order 3 cross 4 is going to have its rank value as 2, then its echelon form is going to be in this format. Have you followed the format of echelon form of a matrix? So here I write the format if we get rank value as 3, and if we get rank value as 2, that also I have written for the example. It is just for the understanding is how it is going to look like when it will be reduced to an echelon form of a matrix. Okay, now to reduce it into an echelon form, we need to follow few steps, transformation step, either row transformation or column transformation. So let us now solve this matrix to get its echelon form by getting its row. So let me erase this echelon form of a matrix for a while, because first we are going to calculate rank. We will confirm the value of rank first, and then we are going to reduce it into its echelon form. So now we have solved sufficient examples on finding rank of a matrix, how to get it. First possible minor of order 3 we are writing. So there is not only one choice of writing a minor of order 3. So among all the choices of minor of order 3, we will select any one choice and we will find its value. Few minors I have here marked in a box in the matrix, that choices we can make. So I have made for the choice of minor of order 3 by having these elements of last 3 rows and corresponding columns in a determinant, and I tried calculating its value, and I am going to check whether it is going to give me any non-zero value or a value 0. So see here, I have performed the calculation to get its value, and in the last I am getting the value 0 for this determinant. Okay, so one of the minor of order 3 from this matrix is giving me 0. So I don't have only this choice of determinant of order 3 from this matrix of order 3 cross 4. One of the choice I have written and I have calculated. So in the rank of matrix, it is said that at least one. So I have written one. I can write more than one, and if any one of them, those values will be a non-zero, then I am through that its rank is going to be 3. Otherwise, I have to proceed with r is equal to 2. If I get the value of r as 2, then I have to proceed with r is equal to 1. Okay, now we are on the calculation of r is equal to 3. One of the minor I have calculated and its value is 0. So I am proceeding with another choice of minor of order 3, and I have a hope of having few such minor of order 3, and if any one of such minors value is non-zero, then I have to stop the calculation of rank over there only. Okay, so now another choice of right minor of order 3 I am writing. Now I am writing these first 3 rows and corresponding columns in a determinant, and then I'm calculating its value. See here, I have calculated another one, another determinant of order 3 from the given matrix, and lastly from this calculation of determinant I get some non-zero value minus 28 at the end. Once I get a non-zero value, I have a conclusion about rank to make over here. What is that? I can write that there exists here one minor of order 3 having a non-zero value. So if one of the minor of order 3 is a non-zero value, then I can conclude that rank of the given matrix is 3. Okay. So no need to go for r is equal to 2. Even if r is equal to 2 for some minor, if it is going to give us some non-zero value, then also our rank is going to be 3, because if we compare 2 and 3, 3 is the greatest number and we are going to get rank value as 3 only. So once we get any one minor of order 3 as a non-zero value, we can conclude that its rank is equal to 3. Now once the calculation of rank of a matrix is done, we will proceed with the conversion of the given matrix into its echelon form. So now its rank is 3. So how its echelon form is going to look like, I have demonstrated it just few minutes back, isn't it? If its rank is 3, how its echelon form is going to look like? First 3 rows and first 3 columns are going to be an identity matrix and rest of the elements are going to be 0. Few minutes back I have demonstrated it. Okay, so in that way only we have to reduce the given 3 cross 4 matrix into its echelon form. So now let us proceed with the elementary transformations to get the echelon form of it. So see here, I have to get 1 at this position where 2 is entered. Okay, because I have to get an identity matrix at this first 3 rows and 3 columns. So how its echelon form is going to look like this only: 1 0 0, then 0 1 0, then lastly 0 0 1, and rest of the elements has to be reduced to 0. This is how its echelon form is going to look like. Because rank is equal to 3, we have just now confirmed it. Okay, so we have to convert the given matrix A into this format. Okay, so that means this first element where 2 is the element at the position of first row and first column, we have to bring 1 over here first. Then after bringing 1 over there, we have to bring zeros at these two places to make an identity matrix of order 3 at first 3 rows and 3 columns places, isn't it? So these few steps are quite clear to us, because such transformations we have performed earlier when we were finding inverse of matrix, and few examples we have seen for finding, for solving system of linear equations. Okay, then let's proceed. So what I can do is I can interchange row 1 with row 3. Why so? Because I have to bring 1 at this position, and that can be done by either row interchange or dividing it with the same number. So why I have interchanged the row? Because I have observed that in the first column I have entry 1 in row number 3. If I interchange row 3 with row 1, I will be having 1 at the position A11. So that's what I have performed to get 1 at the position first row and first column. So the entire row 1 has been entered at row 3, and the entire row number 3 has been entered at row 1. Can you see that? That's the row interchange of row 1 and row 3. So now I can see we have the element 1 over here. Now using this one, we have to bring 0 here and here, where the element 3 and 2 are placed. So we will perform the row operation accordingly. So 3 is placed in R2 and 2 is placed in R3. So we will perform the row operation for R2 and R3. So see the next step of elementary transformation. R2 minus the R1 we will perform, and for R3 we will perform R3 minus 2R1. Okay, to get 0 in the first column. So by performing R2 minus 3R1 in row 2 and R3 minus 2R1 in row 3, we have observed that we have got the first column of an identity matrix of order 3 in the first column. Okay, so the first column has been reduced. Now we have to proceed to reduce the second column for the form of identity matrix. So let's see what we can do next is, now I have to bring 1 at this position where minus 6 is entered. So what I can do is, first I will see whether I can interchange the rows or not. But when we perform row interchange, we have to make sure that we should not disturb the previous changes. That means once we have got 100 at the first column, without disturbing the first column, I interchange it. So I have minus 1 in R3, row number 3, and the column number 2 I have minus 1. But can I interchange? Yes, because in the first column at this position I have zeros. So if I interchange row 2 with row 3, there will be no change in first column. Are you getting my point? I am not supposed to disturb the first column, and I have to bring 1 over there. So there are many ways to do it. If I perform R1 plus R2, Shivam has answered that we can perform R1 plus R2. If I perform R1 plus R2, there will be change in R1. And if I perform R1 plus R2, am I going to get 1 at the position or diagonal position in row number 2? No, that's what we have to see. Exactly. So the next step that we can perform to bring 1 at the diagonal place is, we can interchange row 2 with row 3. Because at row 3 we have minus 1, and minus 1 we can make it 1 by dividing it with the same number, isn't it? So I can bring 1, instead of bringing 1 to it, I can bring minus 1. Then that minus 1, I will divide it the entire row with minus 1. That we can do. That is the easiest calculation as well. So that we will do next. So see, the next transformation performed here is row 2 is getting interchanged with row 3. What we will get by performing this interchange is, we will get minus 1 at this position, which is a diagonal position for row 2 and column 2, isn't it? So at this place in the previous matrix, we have interchanged it with minus 1. So the entire row position of row 2 has been interchanged with row number 3. See the new updated matrix by performing this transformation we have got here. So now I have minus 1 at this position. I can divide it with the same number to get 1 over there. So next transformation that we have performed is R2 divided by minus 1. You can see here in the next updated matrix where we have performed the entire row 2 has been divided by minus 1. We have got 1 at the diagonal position of row 2 and column 2. Can you see that in the updated matrix where we have performed the entire row 2 divided by minus 1? Okay. Now, once the diagonal position has been made 1, then we can use that 1 to get zeros at the rest of the positions in that particular corresponding column. So here and here, that means this element 1 and this element minus 6 is to be converted into 0 now using this diagonal value 1. Okay. So which rows of row operation we can perform to bring 1 to bring 0 to that places? Now we have to perform R1 minus R2, correct? And for R3, what can do? Tell me the row operation for R3, students. R3 we have minus 6. So for R3, whoever has answered correctly, R3 plus 6 R2. Absolutely correct. Have you all followed students how we are performing the transformations to get the identity matrix and entries in the given matrix? See, the next operation for R1 and R3 is R1 minus R2 and R3 plus 6 times R2. Okay, so to the previous matrix, we are performing R1 minus R2 as you all have answered, and R2, R3 we are going to perform R3 plus 6 R2. By performing this row operation to the previous matrix, this was the previous matrix. So we are performing this to the previous matrix. So we can see the change that we have got 0, 1, 0, the desired elements at column number 2 as well. So now we can see the first column and the second column has been reduced. So now whatever next row operation we are going to perform, we are not supposed to disturb these two columns. Without disturbing these two columns entries, we have to perform rest of the calculation to get the echelon form of a matrix. Okay. So likewise now for third row, third column position, that means the diagonal place at the third row is 28 now, and I can now observe just applying a simple logic to make smaller values to the calculation, that 28 and minus 16 entries are both divisible by 4. So I can divide both of the numbers 28 and minus 16 by a common number 4, because both the numbers are divisible by 4. So I am dividing the entire row 3 by 4. Why so? To get the smaller values to the calculation. It's just that. What if I want to divide it? There will be just a few calculation which will be of 2 digits. If I can make a calculation of 1 digit, which will be smaller and easier for us, so just applying a simple logic for easier calculation, I am just dividing the entire row number 3 by 4. Why we are doing so? That idea here. Yes, Shubham has answered R3 divided by 28. That would be correct as well. But then we will get the complicated element of minus at the place minus 6 by 28 we are going to get. And that is going to make complications for the rest of the calculation when we will perform. Okay, Shubham. So we can divide with the common number 4 to the row number 3. So that, see here, if I have divided the entire row number 3 by 4, I have got these smaller numbers. Okay, for this easier calculation for us. Okay, so here now at this place I have got 7 if I divide by 4. And now next thing that I can do is I will divide the entire row 3 by 7. Okay. So that I can get one at the diagonal position. So that I have done. So once I complete doing that, the remaining 2 elements need to be converted into 0. Okay. So that calculation can you all perform like we have performed for column number 1 and column number 2. Now we will be able to perform for column number 3, and the rest of the elements you have to bring 1. Just try to practice these calculations so that you will be uh, having a faster calculation for such things, because at the end we have to get the correct format in less time. That's our goal, solving the problem, isn't it? So some similar kind of row transformations now you have to perform. Get the column number 3 of identity matrix of order 3. Okay. So after bringing one to the diagonal place, we have make them this way. Make the two elements in column number 3 0 using that one. And then the rest of the elements we have been make 0 without disturbing them. Accordingly, we have to perform the elemental transformations. So just give it a try. Few steps are explained by me here. So just in the same way, just try to complete this calculation and then get the echelon form of a matrix. So lastly, we are going to get the echelon form in this manner where I have written I3 and 0. So first 3 columns and rows will be either that means identity matrix of order 3, and last column in the matrix of order 3 cross 4 will be 0. That will be the echelon form of a matrix. So just try to reduce it into such format and get its echelon form of a matrix. Okay, students. So here we stop for today. Hope whatever we have discussed today is clear to you all. So now write your roll numbers in the comment box, and then we will stop this session today. And again, those students who haven't got their roll numbers, just mention your name. So your attendance will be marked by your name. And thank you so much, friends. So here we stop for today.